In this video, I'm going to be discussing redox reactions, also called reduction and oxidation reactions. And all this is keeping track of the transfer of electrons between atoms within molecules during a chemical reaction. And the very first thing you're going to do when examining a redox reaction is assign something called an oxidation state. And the way I like to think of oxidation states is a quote that my chemistry professor had, which was, it's the number of valence electrons that an atom will bring to a molecule minus the number of electrons it will have once it's in that molecule. And so if we look at the molecule HCl and we look at the Lewis dot diagram specifically, we know that chloride or chlorine exists within the 7th column of the periodic table, so it will bring 7 valence electrons to the HCl molecule, but it has 8. And so if we were to assign an oxidation state to the chlorine here, it would be 7 valence electrons that were brought minus the 8 electrons that it currently has, and this would give it an oxidation state of -1. And then looking at hydrogen, because this molecule has an overall neutral charge, the oxidation states must sum to 0, therefore hydrogen must have a oxidation state of +1. Okay, so it's pretty straightforward. And what you'll find if we begin to assign oxidation states to atoms when we're looking at a chemical reaction is that these oxidation states will increase or decrease. And if these oxidation states increase, if chlorine goes from -1 to 0, a more positive number, that is called an oxidation. And if we see an oxidation number go from one number to a more negative number, such as from -1 to -2, that is called a reduction event. And intuitively, what you can think of when you see oxidation or reduction tossed around is the term oil rig. Oxidation is loss of electrons and reduction is gain. And so what I'm going to do now is work through this example where we have water and aluminum reacting with permanganate to form some new species. And so the first thing we're going to make a note of, if we were to draw the Lewis dot diagrams for all of these molecules, is these oxidation states. And so the first thing we're going to do is recognize that the oxygen in water will have an oxidation state of -2. The 2 protons, to keep the charge of the overall molecule 0, will have an oxidation state of +1. The aluminum, because it is in its elemental form, is going to have an oxidation state of 0. And then within the permanganate ion, what we're going to find is that oxygen here is going to have a oxidation state of -2, which is very common, and the manganate, or the manganese atom, is going to need to have, so these, but there's 4 oxygen molecules, or atoms, so you're going to have -8 coming from here, and therefore the overall charge of the molecule is -1. So to get that -1, the manganese atom must have an oxidation state of +7. Okay, and so this is a little bit tricky in here, and I do recommend that you go through it yourself. Moving on though, what we'll find is that within the aluminum hydroxide molecule that's formed, we're going to have the oxygen with a -2, the hydrogen with a +1 oxidation state, and these are going to have -4, but what must happen here is that the aluminum must contribute a +3 to give the overall molecule a -1 overall charge, so its oxidation state must be +3. And what we find once we get to the final species here is that these oxygens are still going to have -2 oxidation state each, so -2 times 2 is going to be -4, and to get the overall charge of this molecule to be 0, the manganese atom must have a +4 oxidation state. Okay, and so now that we've assigned all of these values, what we're going to find if we look at what happens to aluminum, for instance, is that it's going from 0 to +3. And so because we see an increase in the oxidation state, it's more positive now, the aluminum is being oxidized. And if we look at what's happening to the manganate ion here, we see the manganese atom, that is going from +7 to +4. And that is a less positive number, therefore it is being reduced. And now that we've done that, you'll typically be asked on a test to say what is the oxidizing agent and which is the reducing agent. The oxidizing agent is what's reduced. And it's counterintuitive, but the way I like to think of it is the oxidizing agent allows the oxidation event to occur. And so it must be reduced in order for that oxidation to occur. Therefore, in this case, what's being reduced is this permanganate ion. And the reducing agent is what's being oxidized. And in this case, what's being oxidized is the aluminum. Okay, so that's going to wrap things up for this introduction to redox reactions. I hope you guys find it useful, and thanks for watching.